Hi everybody, my name is Rob from RobOps, and today we're going to be showing you how a pod running in an EKS cluster in one AWS account can securely read from an S3 bucket in another account without access keys or hard-coded credentials. This is the first video in a new series of videos going over fundamental AWS architecture patterns. So let's jump in. We're going to achieve the cross-account access by using IAM Roles for service accounts, otherwise known as IRSA. Now, why is cross-account access important? In real-world environments, it's common to have resources split across accounts. Maybe your EKS cluster lives in one account that needs access to data from a central location in a different account. Or you have workloads running in customer environments that require connectivity to your accounts. Traditionally, you'd be tempted to hard-code AWS access keys in your application. While this isn't wrong, it does create unnecessary risk to you and your customers. IRSA allows Kubernetes pods to assume IAM roles directly, using short-lived credentials provided by the Secure Token Service, otherwise known as STS. This gives us least privilege at the pod level and removes the requirements to manage any cloud secrets or sensitive variables. To model this scenario, we're going to create an endpoint on a service running in an EKS cluster that will attempt to access an S3 bucket deployed in a different account. The diagram breaks down these interactions. In account A, we have an EKS cluster running our API pods. The pods are using a service account called API service account. If I quickly flip over to Argo CD, we can see our API pods running along with our service account. For a detailed breakdown of the cluster and surrounding architecture, feel free to check out my EKS experiment series where I break down how I built this cluster from scratch. Now, if we flip back to the diagram, so in account B, we have an S3 bucket that contains a JSON file. This is the file that we're going to try to retrieve using our API. We've also created the IAM role that will trust the OpenID Connect provider, otherwise known as OIDC, from our EKS cluster in account A. When the API pods in account A make a GET request to the S3 bucket, it will present that OIDC token. AWS Secure Token Service will validate that token is legit and issue temporary credentials for the role in account B. Simply put, it will check that the request is from a trusted source, and it will grant permission to that request to use the role that we've configured. And that role will allow us to call get objects on objects inside of our bucket. When we get into the setup, we'll see that we're going to need to set up two pieces of validation to make this flow work. First, the trust relationship between our EKS cluster and our sub-account. And secondly, the lower level permissions to actually access the contents of our S3 bucket. Let's jump into the code. So now that we're in the code, we're going to go over three parts. One is how we've set up the service account that's running in our EKS cluster. Two is going to be the actual endpoint that we've set up in our API to call the S3 bucket and try to retrieve its contents. And the third is the infrastructure that's going to be used to support the infrastructure in the sub-account. So that's going to be the S3 bucket, the IAM role, and the trust relationship. I have PRs for each of these things on my GitHub page. This repository that we're going to be working with, the K8s API, is public. So I'll link the PRs in the video description so you can go check them out in detail as I go over what we've changed. So let's start with the service account. So if I go into my K8s API and I go to the infra directory, I'll go into K8s API charts and then open my templates. You'll notice that we've added a service account YAML, which is our Helm chart that adds a service account. If I go to the values, I can see the details of what I added to that service account. I've provided it a name and I've provided it a very important annotation, which is going to indicate the role, the cross-account role in my sub-account that the service account is going to interact with. I've also updated my deployment and I've referenced the service account so that my deployment knows to use the service account when it's being deployed. Next, we'll go and check out the endpoint that we've created that's going to be calling our S3 bucket. So if we go into our code base and we go to the router.go, we'll see a new function or a new endpoint that we've added at /S3 key. So basically what this endpoint is going to do is it's going to attempt to access or attempt to get object on the key that's provided in the endpoint. So if I go over here to the s3.go, this is the new function that we've added that's essentially going to call getObject based on the bucket, which we've defined in our config here, just my cross account bucket, and the key, which is provided in the request. So essentially, if we go to /s3/ in this case, my-file.json, we should be able to retrieve the contents of that bucket. The last thing I want to go over is the cross-account infrastructure. So if we go back to the _infra directory, there's a cross-account infra folder, and this is going to have the Terraform for the resources that we're standing up in our sub-account. These resources are an S3 bucket and an IAM role and a trust relationship. So if we go into the main.tf, we'll see we have two modules, one for an S3 bucket and one for IAM. The S3 bucket is simply going to create a bucket that has the versioning enabled and public access turned off. But what's more interesting is the IAM module. This is going to set up the trust relationship between our OIDC provider of our EKS cluster and our sub-account. It's also going to create the role that's going to allow the API to perform a get object on the objects in our bucket. Currently, this infrastructure is not deployed to our sub-account. So we do not have an S3 bucket, there's no file or no keys in that bucket, and there's no trust relationship set up. What I want to do is show what would happen when this trust relationship is not set up in our endpoint. So to do that, I'm going to go over to my browser and I'm going to hit the endpoint that we've deployed. So the /s3/myfile-.json, and we'll see what happens with the API. So to do that, I'm going to flip over to a browser. If I go to my API here, it says I'm healthy, hello YouTube. If I go to /users, we can see we have our /users endpoint. If you've seen my past videos, you'll know the other endpoints and the reason they're there. But if I go to s3/myfile.json, if I click enter, we'll get an error. And it'll say failed to fetch object, S3 object get identity credentials failed. Failed to retrieve credentials using secure token service. So because we don't have this trust relationship in place, this is expected. So in order to rectify this, I'm going to go back to my code view and I'm going to go into my cross-account folder that I was just talking about, and I'm going to go Terraform apply. And so this should create my S3 bucket along with my IAM role and trust relationship. So I'm going to click yes, and that's going to create the resources. Now that the infrastructure's been deployed, we can go over to our AWS console and we can see we now have a cross-account bucket set up, which is great. And in that bucket, we have myfile.json. And if I open this file, it just says, hello world from sub-account. Now, if I go over to IAM and I'll go to roles, and I'll see EKS cross-account S3 API-SA, which is the role we created with our Terraform. If I look at this role, there's two things that we want to draw our attention to. The first is the trust relationship. And so this is the first part that I was explaining from the diagram. We need to create a trust between this account and our OpenID provider, OIDC provider from our EKS cluster. And so that is what we're doing here. We're basically saying we're federated with the OIDC from our EKS cluster. And then we make a conditional assume role with web identity on any API pods with the API SA service account. And so what this is going to do is saying any pods in the API namespace that have the service account API SA will be able to establish roles or assume roles from this account. And then the second part of that is the actual permissions themselves. And so if we go here, we can see once the trust is established, then we say you're allowed to use list bucket and get object. And you can only list objects or get objects from the bucket, specifically my cross-account bucket. So the combination of the trust and the role permission is what allows the API to retrieve objects from our bucket. So now if I go back to my slide view and I go back to my browser and I refresh, we'll see that we're now picking up the myfile.json and it says hello world from a subaccount 80225. So as we can see, it's working as expected, and that's great. And so we're gonna hop back to the slides here. So in a nutshell, that's how you can securely give an EKS pod in one AWS account access to a resource in another account. Using IAM roles for service accounts, or otherwise known as IRSA, secure token service, otherwise known as STS, and cross-account IAM roles, we're able to remove the need for long-lived credentials and give you fine-grained control over exactly what your workloads can do. And if you did like what you see, or you want to find out more, feel free to join my Discord. I'll be there. I post video links and have conversations with you all, or my GitHub page. Like I mentioned below, there will be links to the PRs that motivated this video, so you can see the exact changes that I made across the Terraform, the infrastructure, and the API itself. And I also have a blog at robertdipolito.me. So if you're interested, I usually also have kind of like a text version of these videos posted within a week or so of these videos going live. So thanks again, have a great week, and thanks for watching.